is 5.5, solving exponential equations and logarithmic equations. So, before we started really working with exponents, and maybe still now, how about a 2 instead of a 3? 2 to the 5x equals 64. So how we solve an equation like this, so this is an exponential equation, is we have to get everything in the same base. So then I get a calculator out and I figure out what 64 or 2 to whatever power equals 64. So I'm going to look for that. And that number is 2 to the 6th. And then as soon as I have the same bases, so I have them both written in a base of 2, so, and that's how I have to get it to solve it. Then I say 5x equals 6. And I can basically just ignore those bases. I know once I have the same base, I can just set the exponents equal to each other. And then I solve just like a regular equation, whatever I'd have in it. And x will equal 1.2. Okay, so in generic terms, anytime I have the same base with an exponent equal to some base with a different exponent, I can just set those exponents equal to each other. Okay, no matter what I have up here in my exponents. And then we also have pretty much the same rule for our logs. So if I have the log of m with some base, and then I have a log of a different number with the same base, I can do the same things and set those, the things that I'm taking the log of, equal to each other. So now we're actually going to get into the point where logs are actually going to be useful for us. So we have this equation, 3x equals 20. 20 is not any power of 3, so we cannot rewrite it with that base. So what we do is take the log of both sides. So okay, we can really do any log that we want to. The most common one is 10 because that's the easiest one to type in on the calculator because they've already figured those things out for us. So what we're going to do is we then take just the log of 3x. I'm not writing a base because I just assume it's 10 and I want it to be 10. And then I take the log of 20 on this side. Okay, all I've done is just then I'm going to take the log of both sides. And then I use my logarithm rules and I can bring this exponent, which is my x, down in front of the log of 3. So I have x times the log of 3 equals the log of 20. Now I'm solving for x. I want to know what x is. That's even what I wanted to know up here. And then I divide by the log of 3. Because really it's just some number, but we just don't exactly know what those numbers are. So I divide by the log of 3. That's my division symbol there. Divide by the log of 3. And then I have x equals the log of 20 divided by the log of 3. And I'm just going to do that in my calculator. So I'm going to take the log of 20 divided by the log of 3. Make sure when you do this, you don't necessarily have to have the parentheses on the top, but make sure you actually remember this parentheses right here. Okay, and then I push enter, or I can point right here because it's bigger, and I get 2.73. So x equals 2.7. Oh, your calculator, I think your book asks you to do it out to a few decimal places, a few more than I've been having you do. So then let's relook at my answer real fast, and it is going to be 2.768. So I could have 2.768. Did I forget a number? There's a 2 in there. 2.7268. All right, the other way to solve this equation would just be to use your logarithm rules and rewrite this equation here. So I could do the log with a base of 3. I want to figure out what power I need to get to 20. Well, so this one's already solved, and basically I get almost the same thing. What I'm going to do is then use my change of base formula. Okay, so there's a couple different ways that you can really do it. And if you'll remember, hopefully, that I just take my big one divided by my base one. So basically, I will just then have the log of 20 divided by the log of 3. It'll give you the same thing, whichever way is easier for you to remember. I kind of like doing it this way because then I actually see more of what's happening. If you can remember that way, that's good. But sometimes actually just rewriting them, you'll try to put the numbers in the wrong places. So I don't want you trying to mess those up. And remember that you'll basically have the same thing for natural logs. If I asked you to solve e to the 0.08t equals 2500, instead of taking the log of both sides, you're going to take the natural log just because this is the base of e. So then I would do the natural log of e to the 0.08t equals the natural log of 2500, I'm sorry. Then I would bring this out front, and I'd have 0.08t times the natural log of e, which simplifies down very nicely just to 1. Okay, so that is no longer there. It's just a 1 now. And then I will have 0.08t equals the natural log of 2500. And then I will just divide by 0.08. So then I will have t equals this thing, whatever that will give you in the calculator. And that will be your answer. Okay, so let's go through one that looks a little bit grosser. I have 4 to the power of x plus 3 equals 3 to the negative x. So when I do that, I'm going to do the same thing. I'm going to take the log of both sides. So I will have the log of 4x plus 3 equals the log of 3 to the negative x. I'm going to take those exponents out front. Since there's a plus sign in here, I will actually have to use parentheses around it. So I will have x plus 3 times the log of 4 equals negative x times the log of 3. Okay, I'm going to get all my x's on the same side, but in order to first do that, I need to actually distribute through my log of 4 into these parentheses. So I will have x times the log of 4 plus 3 times the log of 4 equals negative x times the log of 3. And then I'm going to get all my x's on the same side. So after I distribute, then I get all my x's on the same side. So I do that over here. So x times log of 3 plus x times log of 3. Basically, since I don't have the same log of 3 or log of 4, since I don't have the same number in there, I can't actually add them. So I will have x times the log of 4 plus x times the log of 3 plus 3 times the log of 4. I really want to get that over to the other side. So I'll subtract 3 log of 4. So I'm going to do that right here. And I'm going to do minus 3. I'll just do an equals over here. Minus 3 log of 4. Sorry about that. So I'll just write it up here. I'm subtracting it here and here. Okay, and then as soon as I have all my x's on the same side, what I'm going to do is then factor out an x. So I write that out front. And when I factor out an x, I'm left with log 4 plus log 3 in parentheses equals negative 3 log of 4. And then to get x by itself, I divide by all this junk here. Divided on both sides, so divided by log of 4 plus log of 3. And then that piece, I'm just going to go ahead and do the little pieces in my calculator. So then I'll have, oh, I exited out of my calculator. So then I have negative 3 log of 4. I'll do that piece on top. And then I have divided by the log of 4 plus the log of 3. Not 33, just 3. Okay, and I get negative 1.6736. Negative 1.7636. Well, probably I could have rounded a little bit better and done 37. Okay, just make sure you type in a lot of parentheses when you type these ones. It looks like your calculator puts parentheses around the piece that you're taking the log of. So put a division bar or a division sign where this bar is, but otherwise use lots of parentheses. So that was one of the fairly gross equations. So now let's do another one that will be equally gross, if not worse. So I have the equation e to the x plus e to the negative x minus 6 equals 0. I can't factor out an x when it's in my exponent. And since I have basically 3 separate things, I can't just take the log of both sides. If I have just 2 things, if I didn't have the 6, it would be really nice. But I have 3 separate things and I don't have basically 3 sides of the equal sign. So what I'm going to do is, before we were replacing things with u's, so my u will equal e to the x. And then I'm going to replace everything. I'm going to go ahead and simplify this out before I replace that. I am going to rewrite this piece here as 1 over e to the x, because that's what the negative x really represents. And since I really dislike having fractions, how we're going to do that is we're going to clear the denominator just like we were doing in our rational functions. So in order to clear the denominator, I'm going to multiply both sides by that nasty denominator. Okay, so then I have e to the x times e to the x plus e to the x over e to the x, because that's what was there before, 1 times that. And then I have minus 6 times e to the x equals 0 over there still. So make sure you have your side equal to 0 when you start doing that, so that this multiplication will work out nicely. Okay, when I have the same base, when I multiply my exponent, when I multiply things with exponents with the same base, remember that I just add the exponents. So I have 1x here and 1x here. So I will have e to the 2x. E to the x divided by e to the x is just going to be 1. So I have e to the 2x plus 1 minus 6 e to the x equals 0. Now I'm going to use this u substitution piece. And what I'm going to redo is actually write all my exponent guys in descending order. Because if I notice that this is really not terribly similar to a quadratic equation, but still fairly similar. So I have e to the 2x minus 6 e to the x plus 1. Okay, the reason why we're going to do the u substitution is we're going to say how many e to the x's do we have right here. Since I have two of them, this will be u squared. This will be 6u plus 1. Okay, that's not going to factor at all. I cannot think of anything that multiplies to 1 that's going to add to negative 6 because it doesn't exist. So I'm going to use my quadratic formula. Okay, my a is equal to 1, my b is equal to negative 6, and my c is equal to 1. So when I actually do this, I'm solving for u. So I have u equals negative b will actually be then positive 6 plus or minus the square root of b squared, which will be 36, minus 4 times a times c all over 2 times a. And then when I simplify that down and I'm solving for u, I'll have 6 plus or minus the square root of 36 minus 4, so 32 over 2, all over 2. And then I'm going to re-simplify that down, and I'm going to factor down 32, so 32 factors down into 4 and 8, which is 2 and 2, another 4 and 2, another 2 and 2. So I have two sets of 2 that can be pulled out. So when I re-simplify that square root of 32, I have 6 plus or minus, no longer square root. I will have 4 square roots of 2 because I have the 2 left over here. So that's the one that gets to stay inside. And then I multiply these two to get that 4 all over 2. And then I can simplify everything. I can divide everything by 2, not the thing in the square root. So a 2 goes into this one once, a 2 goes into this guy twice, and 3 times. Since I have a 1 on bottom, that works out nice now, and I'll just have 3 plus or minus 2 square roots of 2. And that is what u equals. But then I have to go back and solve this equation. Since I know what u equals, I can figure out what e to the x equals. So then I'll have e to the x equals that same stuff. And then I know how to solve an e to the x equation. Okay, I'm going to take the natural log of both sides. That's how I undo an e. So I take the natural log, I take the natural log of this stuff. And then when I take the natural log of e, I'm just going to be left with x equals the natural log of 3 plus 2 square roots of 2. And then I'll separately have to do the natural log of 3 minus 2 square roots of 2. So I will get those two answers when I do this. And I will take the natural log of 3 plus 2 square roots of 2. I don't want my parenthesis in there. I want to come out here and do my parentheses. Enter, and I get 1.7627. 1.7627. And then I'm going to go back and do my subtraction piece. And so on your calculators, if you don't know how to just quickly retype something, I do second enter, and that will give me back my same equation. And then I'm going to go plug in a minus sign instead of a plus sign. Enter. And I have negative 1.6727. The other method to solve these equations that are kind of gross like this, honestly, and they're hard to work with, and it is sometimes hard to actually remember all of your rules. So what we're going to do is go in, and I don't know why I have to have so many equations typed in. I'm going to actually type in this equation up here. So I have e, so I can do my e to the x button, which will be down here with the natural log. Or otherwise, I just have a plain old e that doesn't have its own power, will be here on that division symbol when you do the second button. So I have e to the x, make sure I get out of my exponents, plus second natural log of negative x, get out of my parentheses, minus 6. When I go look at that graph, sorry about the second graph down here that you probably don't really actually want to see. So we don't actually need this guy here. I just had way too many things typed in my calculator. And I can take my approximation of this guy. I wonder if I can drag and drop this over here. That's fancy. Anyway, I'm going to do a calculate kind of thing. And I want to find where my zeros are, so I'm going to push 2. And my left bound, I take my arrows and I wait till my cursor is around right here. So when I see it, that'll be great. I'm going to find my left bound. Okay, I want it on the left side, which is actually above the x-axis. And I'm going to press enter, and then it's asking me for my right bound. So I go down. And I have to make sure if I'm checking out my y values, as long as it's below the x-axis, so as long as my y values go from positive to negative, it'll find something. And then I go, it wants me to guess somewhere in between here. And it tells me 1.76247. Woohoo, my calculator can do this stuff for me. And then I need to go back and find this 0 then. So then I have my second calculate menu again. It'll only do one at a time, so you can't try to make it do both. My left bound, I now want it to be way over here. So I need to make sure I'm watching my y values to make sure that I didn't actually skip my entire screen. So as long as it's still negative, I'm happy. Okay, I could probably try to go faster. Okay, I can see it now. As long as I can kind of see it on my screen and it's going too fast. Oh, and there it went. Oh, that's awful. Oh my gosh. I'll just pause this. Alright, and then I'm back to my calculate menu. And I'm going to do my 0 again real fast. So hopefully you got the idea from the last one. Okay, as long as it's below my x-axis now, because that's what's on the left side. Now it's asking me about my right side. So I have to make sure that I'm picking something that's positive. So that's not positive yet for my y values. That is positive, 0.93. It's asking me to guess, so I push enter one more time. And it says my 0 is at 1.627. I'm going to get the same values either way, but using your graphing calculator might actually be a faster method to actually go through and do this. So I really didn't need this screen down here. Okay, I'm just going to go through solving a couple different types of equations for you. If I am given something like log base 3 of x equals negative 2, what I'm actually going to do for something like this when my x is inside my log piece, it's a piece I'm taking my log of, I'm actually just going to rewrite my equation. My base of my exponent is 3, and my actual exponent is just negative 2 equals x. Okay, then I'm just going to simplify this. So then I'll write 1 over 3 squared equals x, which will just be 1 over 9 equals x. I can check that in my calculator real fast by doing a change of base formula, or sometimes it could just be easier to actually plug it back into your original formula. If I have log 3, base 3 of 1/9 equals negative 2, I just want to check that out and make sure it works. 9 is 3 squared, so I have log of 3 over 3 squared. And since it's in the denominator, I'm going to bring it back up. And my exponent will be negative 2. So I have 3 to the negative 2. I bring that negative 2 out front, and I have log 3 equals negative 2. That goes to 1. Good, that checks out. Okay, so more examples. I want to solve the equation log of x plus log of x plus 3. equals positive 1. When I have a plus sign between my logarithms, I'm going to rewrite that with my product rule, and I'm just going to have a single log of x times x plus 3 equals 1. And then what I'm actually going to redo or do is to rewrite it with as an exponential form. Okay, basically this looks a lot like the one we just have where I had an x inside my parentheses over here. I have to remember that my base is actually 10 because it's just a normal log, not 16, 10. And then I rewrite it. I have 10 to the power of 1 equals the stuff I have here in parentheses. X times x plus 3. I'm going to distribute that x throughout thing. 10 to the first power is just 10 equals x squared plus 3x. I'm going to get that 10 over to the other side. So I'm going to subtract 10 from both sides. And then I'm going to try to factor it. What factors down to negative 10, what multiplies to negative 10, that will add to positive 3, and that will be a positive 5 and a negative 2. Okay, and then I just say x has to equal negative 5 and positive 2. And you really do need to get into the habit of checking your answers back to your original equations, because not all the time will they work. So I'll just check this out. So if I have log of negative 5 plus the log of negative 5 plus 3 equals 1. So I'm going to get my calculator out, because who wants to try to get 5 into one of these things? So I'm going to just go to my home screen, and I'm going to take log of negative 5 and see what I get. And it gives me a non-real answer. So I just have to remember that I cannot actually take the log of a negative number. Okay, so this one is not right. So negative 5 is not an answer. I'm going to real fast do log of 2 plus the log of 2 plus 3. Is that equal to 1? So then I'm going to do the log of 2 plus the log of 5. Is that equal to 1? And then I'm going to rewrite it with my powers, and I will have the log of 2 times 5. Is that equal to 1? I have to remember that my base is still 10, and that will help me actually do this problem. 2 times 5 is 10 equals 1. The log of 10 with a base of 10 is equal to 1. So positive 2 is my only answer. And that doesn't mean that you're not going to have a negative answer. It just means that I cannot plug a negative sign in here and get out anything real. So if it had different pluses and minuses, then I could have possibly got a negative answer that would work, as long as I'm not taking the log of that negative number. Okay, just a couple more examples. The next one we'll do is solving the equation log with a base of 3 of 2x minus 1 minus the log of base 3 of x minus 4 equals 2. Then what I'm going to make sure that I do is rewrite everything first with my quotient rule, since it's a subtraction between my logs. So I will have a log with a base of 3. My first one goes on top, so 2x minus 1 over x minus 4 still equals 2. And then I have to remember that I now have x's that I'm taking the log of, so I'm going to rewrite it as an exponential equation. 3 is my base, 2 is my exponent, equals the stuff that I was taking the log of, 2x minus 1 over 3x minus 4. Okay, 3 squared is 9, so I have 9 equals that same stuff, 3x minus 4. I don't like 3x minus 4 on the bottom, so I'm going to multiply both sides by 3x minus 4. Okay, 9 times 3 will give me 27x minus 36 equals, those guys will actually cancel out if I had it as a fraction, equals 2x minus 1. Get all my x's on the same side. Minus 2x. And then I'm going to add 36 to the same side as well. Okay, so I have 25x equals positive 35, so I don't have to write a plus sign. Divide by 25. And I'm looking at my stuff here, and I have absolutely no idea where I got this 3 from. I just totally made up that problem. Okay, no 3 here. Sorry about that. No 3 here or here. So then I would have 9 times x, which will give me 9x. 9 minus 2 is 7x, so I'm not dividing by 25. I'm dividing by 7. Sorry about that. And then I get x equals 5. Alright, x equals 5. I'm going to plug that back in up here and make sure everything works out. Okay, so I'm going to have the log base 3 of 2 times 5 minus 1 minus the log of 3 of 5 minus 4 equals 2. So then this will give me 2 times 5 minus 1 will be 9. So I have the log of 3 of 9 base 3 minus the log base 3 of 1 equals 2. The log of 9 with a base of 3, I could really write 9 as 3 squared, so that's 2. 1 is really 3 to the 0 power, so 2 minus 0 equals 2. Good check, because 2 minus 0 is 2. Okay, so that means that 5 is our solution. And one more example, because there's just so many different things that can actually happen with logs. So hopefully now you're pretty good and you feel comfortable working with them. But one more, that's a 6 minus the natural log of x plus 5 equals the natural log of x. Okay, I rewrite things with my quotient rule. So I'm going to make sure that that looks like a 6 so that I'm not trying to plug in random numbers. So then I take the natural log of 4x plus 6 over x plus 5 equals the natural log of x. Anytime that I have the natural log, what I'm actually going to do here is I'm going to take everything, I'm just going to use my property of equality. So it was back at our very beginning thing. So if I said if I had the log of the same base equals the log of the same base, if I have two different things here, I can just set them equal to each other. Natural log means that I have the same base because I have an e. So I just take those and set them equal to each other. So I have 4x plus 6 over x plus 5 equals x. Okay, I feel comfortable that you guys can solve that. So I have 4x plus 6 equals, when I multiply x plus 5 times x, I would then get x squared plus 5x. Get all my x's and stuff on the same side since I have an x squared. So I'm going to subtract 4x and subtract 6. So I'll get 0 equals x squared minus 1x minus 6. Okay, what multiplies to negative 6? That will give me 1. I'm going to factor that down, and I will have x minus 3, x plus 2, and then x will equal positive 3 and negative 2. I plug those back in to check those answers, and then I will get the natural log of 12x plus 6, not x, just 12 plus 6, minus the natural log of 8, and I want to see if that's equal to the natural log of 3. So 12 plus 6, I will get the natural log of 18 minus the natural log of 8, and I want to see if that's equal to the natural log of 3. 18, the natural log of 18 minus the natural log of 8 will give me the same thing as the natural log of 18 divided by 8, which is not equal to 3, because 18 divided by 8 is not equal to 3. But hopefully you guys noticed that I messed this problem up too. I'm sorry. This should be positive 1, so that will make these signs change, which will make these signs change. And I really don't want to do positive 3. I want to do negative 3, which would have been negative 12, and not that number. In any way, the natural log of negative 3 doesn't exist, so I can't do that one, so that can't be a solution. So now actually, hopefully 2 will actually work out, since I'm terrible at checking my own answers. So then I have the natural log of 8 plus 6 is 14. I'm putting it back in the original equation. And then I take the natural log of 2 plus 5, so 7. And I want to see if that's equal to the natural log of 2. Subtraction really means that I'm going to take division, so I'm going to do natural log of 14 over 7. Is that equal to the natural log of 2? And yes, it will be. Oh my goodness. And then that will be all of the notes for this section. I want you to do homework on page 448. And I'm giving you lots of numbers today, but it will be all odds, and I have 1 through 61 odds. So about 30 problems still.